Any idea how AI agents can solve problems or perform tasks like a human? In this video, we'll deep dive into the basics of AI agent powered by LangGraph. We'll see how they think, learn, and make decisions. Let's start with some basic building block of LangGraph. Uh, LangGraph is a graph-based framework, so it will have nodes and edges first. Let's talk about node. Nodes are some function that can actually call LM. It can call tools. It can have its own custom logic and all. So it can have LLM call. It can call tools, and also it can have its own custom logic. Next is age. Edges are nothing but connectors. So if we have multiple nodes, edges are connecting those nodes, and it will actually define the flow throughout the graph. Next we have state. State is a very important one here. Let's discuss state in terms of message state, because we are just talking about some chat type of application first. And let's say I'm calling this node. This is an LLM node, and I'm just passing a simple hello, right? And this node is answering, this LLM is answering, how can I assist you? Right. So how the state is stored? State will be stored in every node. And how the state is stored, basically, let's say it's a dictionary kind of structure. Let's say state is having one key called messages, and first I got hello, I'll be adding it to the state. Next, in the next node, in the next in the first LLM node, we got how can I assist you, then I'll be adding it here. So this way, this is a dictionary structure that is maintaining the flow of information. So if we have a complex graph like this, and so on, like right there, so the path graph will take at each node, it will produce some output, right? And that should be added to this message state. And of course we can modify some state messages, or we can add some, we can remove some messages and all. And it should not be always messages, it can be any other keys as well, but it's basically a dictionary kind of structure. LangGraph has its own inbuilt message inbuilt state classes as well, that also we can use, but it's basically to maintain the state at each point of the graph. Next, we need to talk about tools. What are tools? Let's say I'm calling an LLM node. So this is an LLM node, and I'm passing a simple question like, how is the weather in Bangalore today? Right. So this node, LLM node, understands the question, but it doesn't have the context, right? It doesn't have access to the latest weather data, latest newspaper data, and all this, right? It cannot access any other external APIs as well. So, and the LLM was created at a certain point of time, it doesn't have access to this latest information. So what we can do is we can bind this LLM with some tools. So let's say, what is a tool? Tool can also be a function Let's say for this case we have a weather tool that takes a city as input and it returns the weather. Let's say weather info, right? And we create a tool with like this with add tool, and this is how we create a tool. We can use some inbuilt tool as well, but when we bind a tool with the LLM can decide whether to call the tool or not based on the question. Like for this question we passed it, how is the weather in Bangalore, it doesn't have the context, so it will just decide whether to call the tool or not, and it here it decides so that yeah, so we have to call the tool. So what it will output, it will not directly call the tool, it will output a tool call. So it will output a tool call with the name of the tool is weather and arguments is Bangalore. This the LLM has already found from this question. How it got the argument from this question, it decided it understood that the key should be Bangalore, we need the weather for Bangalore, so it will decide this is the this is the tool called weather and its argument should be Bangalore. Now let's discuss some basic idea or motivation behind an agent. So let's think about a single LLM node, right? LangGraph has its few own inbuilt node like start and end. So these are some entry and exit node, you can say, and this single node doesn't have access to any tool or any external content, right? So it won't be able to answer everything. And one more thing is it cannot create multi-step workflows. So suppose we for some operation we have to perform multiple steps, first do this and then call this LLM, then do the some other thing, and all this type of complex flows we cannot create with a single node. So we need multiple nodes there. And like suppose if we have one node and we are binding one tool with it, then in that case LLM can decide whether to call that node or not, call that tool or not. So if it decides to call the tool, then also it will not actually call the tool, it will output the tool call with the arguments. So we need multiple nodes, right? So let's create a chain type of flow, right? So here let's say for LLM, this is LLM can be called any point of the time in this flow, and we have this is a step 1, let's say, and this is step 2. And so in if LLM decides to call a tool, so this step 2 can be basically a tool node which will actually call the tool, right? And it will give the result. So this is a chain type of flow we have created where we can have steps before or after LLM. The problem with this chain type of flow is it is a fixed flow and LLM doesn't have much control like which node to call and all, right? So here comes agent, which is a control defined by LLM. So suppose if we have multiple steps, right? So let's say we have step 1, step 2, and let's say we have n number of steps, right? So LLM can decide, and this is an LLM node, and so LLM can decide from this n number of nodes to call like which node it wants to call. So it can start with step 1, then it can go to step 3, then again go back to step 1 and so on. So the whole flow will be defined by LLM. So this is the basically the idea behind agent, which is control defined by LLM. Now, this is a fully autonomous agent, because if we have n number of steps and LLM can choose between n number of steps, so this is a fully autonomous agent, right? And this is a fully autonomous agent, but it has observed that the more autonomous an agent is, the less is its reliability. So the application reliability will be less if the agent is more autonomous. So we can keep certain things fixed, and we can uh, inject LLM wherever we need it. So let's see the idea here. Let's start with a simple router. What is a router? So let's say this is LLM node, and we have step 2 and step 3, and LLM has to decide between step 2 and step 3. Here LLM has to decide only based on only from two nodes, right? So this is called a router. And like the steps we can fix a few, also we discussed like we can keep few steps fixed, right? Let's say this is a start node, right? From the start node it will always go to this node, and from it will always, the agent will always end from a certain node. So this is a step n node, and in between if we want to inject LLM anywhere, so we can do that, right? So this type of flow we can create for our application. Next, we can have loops as well. Let's see how. uh, let's say we have an LLM which is calling a tool, right? So it can happen that after the tool node calling, so this tool node will give some output, right? So after getting the output also, we can have, maybe we, for some other processing, we have to go back to LLM. So this will create a loop, or it can happen that the LLM has to regenerate its output again and again, right? So this type of loops can exist in our agent, right? So yeah, so this is the basic idea behind AI agent with LangGraph, and we can start creating some cool agents now. Thank you.